Hey everyone, in today's video we are going to talk about a very important concept in compiler design, the intermediate language or the intermediate representation, often referred to as a IL or IR. This concept acts as a bridge between the source code and the final machine code. So let's break down it in a simple and clear way. So firstly understand the what is the intermediate language. Before going to start the exact topic, we will see the introduction of this. In the introduction, a compiler is a program that translates a high level language into a machine code, but it doesn't usually convert it directly from the source code to the machine code. Instead, it goes through a multiple stages, and one of those stages is generating the intermediate code or the intermediate representation. So, what exactly is an intermediate language? It is a low level, not as an abstract, as a high language, but not as a specific as a machine code. It is like a middle ground of a language that is easier to optimize and portable to across the different machine architectures. For example, if your source code is written in the C language and your target is 86 machine code, the compiler first translates it into a C and then into a IR, and then you will get a 3 address code then from the IR to 86. So why we use the intermediate languages? So let's understand. Firstly, the machine independence. So we use this because of the machine independence. Machine independence. IR makes the front end of the compiler independent from the back end, so you can reuse the front end for the different target machines. Okay, second one is the simplifies the optimization. It is easier to apply the optimization or the on the IR on a raw source code or the machine code. Third one is the compiler efficiency. Using the IR breaks the compilation into a manageable stages, that is the front end and the back end. Retargeting made easy. You can change the back end for a new machine without rewriting the entire compiler. So now let's see the types of the intermediate languages. So the first one is the high level, middle level and the low level. What is the high level intermediate representation? It is closer to the source languages, preserves the high level constructs like the loops, if else, etc. For example, the abstract syntax tree. It is used for all syntax, directed translation and the semantic analysis. The next one is the medium level intermediate representation, a balanced form, easier to analyze and optimize, often used in a middle phase of the modern compilers. For example is the LLVMIR. The third one is the low level intermediate representation, closer to the machine language, like an assembly version without any specific architecture. For example, 3 address code, register transfer language. These all are the example of a low level. So why it is widely used in the IR? Because it is having the 3 address code, that is the tag uses the temporary variables. For example, T1 equal to A plus B. We can store the temporary variables into this. Control flow graph, that is the CFG, represents how the control the flows between the blocks. The third one is the SSA, that is the statistic single assignment. Each variable is assigned exactly the once. The fourth one is the LLVMIR, that is widely used in the modern compilers like the Clang and the powerful and the modular. After that, all these are comes into the intermediate languages. So in the conclusion, like it is the middle layer enabling the optimization, portability and clarity in the compilation. Whether you are designing a compiler or learning how one works, understanding the IR is the must. So thank you so much.